All set. Let me open the participant list. Okay, all right, everyone. Thanks for coming. My name is Peter Lee. I'm from the R3 Developer Relations team, and today we will have a sessions on Corda design pattern and then good practice. I think it's already 4 minutes past our starting time. Let's just give another minute for people to join. So we can start. I actually see quite a few familiar names in the audience. Yeah, welcome back. Today's session is sort of like one of the, how would I say, advanced topic. After you learn about the Corda 101s, after you learn about how to write your Corda app, after you get familiar with the coding, this session is to help you look at how would you properly design a production grade Corda app. And I think this is a webinar session. So I couldn't see your chat, if I'm correct. Yes, you guys are not able to, like, we are not able to communicate in the chat, but you can ask questions in the QA. Yes. So yes, anytime during the sessions, if you have any questions, just drop it in the QA, and then I will answer them live. The session looks like it's recorded, but for this session, it's interesting because we are taking one of our CordaCon topic, and then we really think the content is useful for the community. So we take the content from CordaCon, and then this team, we are representing it to everybody. So it will be recorded, but we actually suggest you to go on to r3.com and then you watch the original content, because original session has 3 use cases. For my session, I only gonna cover 2 of them for the time reason. And yeah. Okay. I guess we have quite a group of audience. Let's get started. Yeah. Okay. Corda design patterns. So why are we doing this? So today's sessions, we're gonna break into 4 parts. Each part take like 10 to 15 minutes. And if you guys have questions, as I said, QA. If you have questions, yeah, drop in the QA. And the question is, please share the link for the original sessions on r3.com. Yes, let me actually find it for you. And I'm actually curious if I share, like, answer it in the QA, will everybody see it or just you see it? So let me actually try. So let me actually answer the QA right now. Type answer, put my answer there, boom. I just shared the link in the QA. So you can also tell me if you guys can see it. I think all of our employees, as a panelist, we can see the QA, but I don't know, as an external audience, can you all see the QA? If you can, maybe give me a thumb up, or like raise a hand or something, because I think I can see raising hand. So if you can see the link in the QA, okay, perfect. I see Nick raise his hand. Yeah, perfect. So let's do this. If you have questions, we will answer it, and then we will type the answer in the QA, and then everybody can see it. Okay, cool. Okay, perfect. Okay, let's back to the session. So we're gonna break into 4 sections. The first one is what exactly is the Corda design patterns, and why should you care about it. Second is anatomy of the Corda design. Is like when we're doing the internal studies, what we learn from our Corda customers, or they like to call it the Corda fraternity. And then the third, we're gonna show two examples. As I said, original recording has 3 examples, but for my sessions, I'm gonna do 2, so we can talk it, like break it down and take it a little like slower, because it's an online session, it's not an in-person session, right? So the knowledge delivering probably might be slow. And the last, we want to show you, like, when you're actually coding, what are some of the good practice that you can do for your Corda. We never say best practice, because there's no best practice. We always learn from the mistake. So we can only say what we recommend are the good practice of writing a Corda. Okay, so the first section, why are we doing this? What are the Corda design patterns? So we would like to think the Corda design patterns are suitable for standard solutions for general Corda app development, deployment, and operational problems. And some, general problems can be technical problems, like how you can do manage assets control machine, like bank machine, network management, rule-based contract validations, health checks, ledger, database sync, and SaaS buildings, or domain-specific problem like observer node, settler, deliver versus payment, payment versus payment, and last, pattern node to work in the most scenarios from the expertise. So those are what we call the Corda design patterns. And why would you care about it? Is to prevent reinvention of the wheel. Like, the things we, as basically the maintainer of Corda, we see our customers, like the progress or the mistake we see our customer make, we want to share with everyone. And we actually encourage everyone also share with us the caveats or the hiccups they run into. So we can basically make everybody benefit from, learning from each other. A contract of like the right and the incorrect way to develop your Corda, deploy your Corda, encourage conversation brevity, and archive of rich pattern to vet, suggest, and improve better understanding of the Corda platform. And lastly is prefer the platform improvement. So basically makes everybody improve together. So that's what we think are the patterns and why should we care about. And what in terms of patterns, then what is it? So we want to look at it from the 3 angles, or from 3 perspectives, coming up with your Corda design. So the first one is identifications, the second one is pattern core, and last one is behavior. So those are the 3 angles we would recommend if you are building a production ready Corda app. Those are the 3 aspects to think about the problem. So in the identification phases, so you need to basically ask 3 questions. So what does the pattern solve? Like what's the business problem or the technical problem that you want to solve? And second is the use cases, where to deploy your solutions. You are writing an app, you want to put it into use. You are not writing an app for the sake of writing apps. It's like us writing samples. No, you are not doing that. We get paid for doing that, but you don't. So that's the second question. The last one is the caveats. So the pitfall and areas where the pattern does not apply. So this is an interesting part, because you need to be thoughtful and then careful of what problem that your solutions cannot solve. You need to make it very clear. We came across customers, they dream big, right? But dream big is not a bad thing, it's a good thing, but you need to be, at the end of the day, come back to realistic of like, you know, you gotta solve small problem bit by bit, and then you can reach your big dream. So the last one is what problem that's a DLT solutions or Corda solution cannot solve. So there's one famous, well, I mean, I wouldn't say famous, but I would say there's one common problem that people think DLT can solve. People think DLT can be a solution is, you know, to deal with bad people doing bad fraudulent stuff. But I can tell you, no, a DLT system, or not even Corda, any DLT system cannot solve that problem. You know, we can try to make it prevent all the attacks, you know, as much we can, but we, at the end of the day, we can't make a system that's just like prevent bad people. You know, if people become doing bad behaviors, they can do it in any system. So in that term, no system is secure. But also on the other side, you can't keep into trap yourself into basically the chicken or egg questions. So that's one example. So DLT does not solve problem bad people behave badly in a business transaction. If they want to set up like a fraudulent transactions and they are like the node operator, well, he can do whatever he wants. So the DLT can capture like all the trace of that happening. But you know, if you want to ask, like, can DLT basically stop that from happening? I would say no. I mean, of course, you can set a lot of rules to make it difficult. But if that bad person is the operator of the system, then there's not much you can do. To make it 100% bulletproof is just not possible. So yeah, so that's that. 3 core questions when you design your production level Corda in the identification phase. Next phase, pattern cores. So there are 5 angles of it. So you want to ask yourself, so the design that you are putting, like you invest your time in, you invest your effort in, are those technical or domain specific problems? Are you trying to solve like something that is like more leaning towards the business logic level, or is just from the operational perspective, you make operation faster, you know, the technical? And from the solution level, how does it solve the problem? So that's another thing. And then next, on the architecture level, we have the Corda design language. We have we did a session before teaching about how you can use basically charts or diagram to design your architecture. So that's that. And lastly, you know, relevant Corda concept, state, contract flow, the network, RPC, you know, all those Corda bits. So that's in your pattern core. And lastly is anti-pattern. So knows the incorrect way to solve a problem. So you can hard code stuff to solve a problem. That's just gonna create more problem. And lastly is after you identify the problem, you know, realizing and then design your pattern core, realizing, you know, what you want to solve, what you can solve, how you're going to solve it. And you also need to observe the affected non-functional requirements. So it's from your application, right? So what's other aspect that is gonna affect from, you know, integration, like external integration level, from working with the other sort of like related bits of your Corda. So those are not in your design, but you need to consider that, because you are not basically creating a software that's not talking to any other system, like isolated software, because that's no use. Or if you can really sync one that can make money, also that's good for you. So those are the three angles when you're coming to Corda design patterns. We would like you as I would say developer or the operator of the Corda app to look into identification, the pattern core, and the non-functional requirements for the behavior of your system, your applications. So we're gonna quickly show a demo of two examples in the context of digital asset, not too much on the digital asset, because originally the second example has something doing with like payment with a chip, but I'm not covering that for today. But for the two showing on the screen, I think those content are already interesting enough. So I would like to share with everyone. So the first one is out of node payload signing, aiming to solve a problem that's a lot of our customers wanting to solve is basically out of node signing. And the second example I want to share with everyone is the ledger and off ledger data synchronizations. Those are real problems that we encounter, and we hope to, from let's say from the design or from the architecture of how we solve the problem, can give you some idea of how you can basically solve if you run into any issues when you design your Corda. So now we are already in the third part, example patterns, right? So the first one is out of node signings. So the problem is end user authorizations on transaction, they want to use their own public key or private key, public and private key to sign the transaction. So if you are familiar with Corda, you will know that Corda holds all of the public key, private key pairs within the node. And a lot of people, I mean, if I say they don't like it, it's very subjective. I would say they have demands for using out of node signing. So in a very simple example, so let's say I have a public key and private key pair on my phone, right? So I want to use that public private key pair on my phone to sign the transactions. But if you just use the default design or architecture of the Corda platform, it's not allowing you for doing that, because all of the public and private key pairs are generated within the node, and then the nodes holds full responsibilities or control of those public and private key pairs. So how are we gonna basically get away from that? And then what are the solutions? So we will register the end user public key on the ledger, and then require critical business transaction to sign by the end user verified transaction inside of a contract. So how are we doing it? So from looking at the chart, the diagram here. So imagine you have a state, which is application state, is whatever property that you are dealing with on the ledger. It can be a car state, a loan state, business related state, Corda state. And you will create another state called account key state. And then inside of the account key state, it has very simple thing, the user ID and then the key. And that's actually the public key of your that you stored on your external device, your phone or something. And you will have a signature algorithm on the left that basically can take in that private key and then magically cross-check with your private key. And like, we are not going to talk about the signature algorithm but it's from this setup, what you can achieve is basically whenever you are want to do a create application state during the create, the signer, one of the property on the application state is the signing key of the account key state, and then you can set up a linear pointer directly point to your account key state, and then get the public key from the account key state, and then using the signature algorithm to match, basically to check if this is the key that you already no, sorry. If every time you want to create the application state, your public key on your phone will be registered with the flow, and then in the flow, it will go to the account key state, and then using the signature algorithm to calculate and then make sure the key you are having like in your mobile phone is matching the account key state's public key that you stored already on the ledger. So that's basically how you achieve use like signing with external public and private key pair. So basically, is you are adding an extra step from the original Corda platform routine. You create a state, you using the in node public and private key to register the transaction. But before you do that, you use your public and private key on your mobile phone to check that if that's key you are inputting into your flow is the correct one that's that you stored on the ledger. And looking at the life cycle of the system. Oh, I have someone at the door. Sorry, let me quickly get that. Oops. My bad. Okay. So where are we? The life cycle management of, oh yeah, okay. So you the use case specific onboarding with Alice private key to basically register with your account key state, and then you cross check with the contract, and you verify that account key state is basically like the public key you hold in your mobile phone is legit, and then you can proceed to your application state. And if you, for example, you lost your phone and then you want to update your keys in the ledger, you just update the public key stored in the account key state on the ledger. You do that, and then that's on the network operator level. So revoke, you can update or revoke public key during offboarding or blacklist. So looking at a solution like this, in summary, the use case is off the ledger signing, and from the relevant Corda concept are the state and the contract, because you are registering the public and private keys into basically a new state, and then you are using contract to verify the validity of your mobile public keys. And the effect non-functional behavior of your design is it adds extra decentralizations on your system. So you solve the problem that all the public and private key pair currently by default is held within the node, but now adding this extra layer, you will somewhat achieve a little bit more decentralizations in that sense. And of course, the downside is the simplicity of the setup is going down, because you are constantly basically you are adding a new state. So every transaction that you are working with, you are basically add another factor to your transaction. I see a question. So the first example is when using Corda accounts. I did not understand the problem, I guess, if this is about nodes. So it is not really about Corda accounts, but you can use it with Corda accounts. So, okay, so let me explain the problem again. So in short, okay, let me say this. So if well, okay, so if you have been working with a Corda app or like operating the Corda node a little bit, you will know that the public key and then private key pair, all those like the encryption stuff happened within the node. You cannot sign a transaction outside of the node. And in like right now in the public blockchain space, every public blockchain will have wallet, right? The wallet is basically the idea that you hold your own public key. You don't want a node or third party to hold your public key, but at Corda, you must have the node to hold your public key and then private key, and then every time you do a transaction, the node will basically sign off the transaction using the public key and the private key generated within the node. But sometimes, setting up a node is expensive, right? Let's say we have 10 customers. If you want to hold your own public key and private key pair, and then join the network, join the business group, what does that mean? It means you need to set up your own node. You will be the 11th node, and then that will have costs associated with it. But if you want to go cheap with the business, but you still want to be part of a DLT, or still want to be part of a Corda network, you can go to one of the node and then say, okay, I really like that network. I really like Corda. I want to be part of the network, but I don't want to set up my own node. And then the other node operator or the existing member say, okay, you can be a sub account under me, or just forget about account. You just be part of my organization. We can have some like off the ledger agreement. But then you will say, but I kind of want my own public key to sign the transaction. Like I trust you, but I don't trust you 100%. So some of our customers, they are dealing with that issue is they are a consortium, they're a group of smaller customers under one big node, but sometimes they want to sign not using the node's public key and private key, but they want to sign with their own public key and private keys to show that, okay, that's really real, that's really me, not my parent company or not my umbrella node company. So that's basically this example explains how you can achieve that by setting up additional steps when you sign the transaction. Okay. Okay, so if I explain the problem well, whoever asked the question, can you like raise a hand? Liza, yeah. So if you raise your hand, meaning that you get what this solution is solving, then I will move on to. Yeah. Okay. So continue to the problem. So you just like follow up with the question. So you say, but the parent node will still sign. Yes, but now is if your signature is not on the transaction will not proceed. So that's where is like it. So that means you get control of the transaction. If you don't like it, even though they are your parent company, they see all your transaction, but if you don't like it, the transaction won't make. So that's basically solve the problem. Yeah. Okay, perfect. You got it. But let me go on to the next question. Can I explain once again how exactly that worked? Okay, so that's basically this diagram. So basically, originally, if it just by default, just from the node to node level, there's no, you don't want to use an external public key. So everything is just on the left. No, not even left. It's just in the middle. So you have an application state. You are writing your properties into your state, and then you transact that state. And then the node will put its signature on the transaction. That's it. It's very straightforward. But now, adding this extra step called account key state. So the account key state only does one purpose, is to register the public key of like some external public keys that you're holding on your mobile phone. Like, so that public key right now on the screen, you see the red box records the external public key you want to use every time you want to sign off a transaction. And then what happens is, when the next step is doing a creation of application state in the contract, well, okay, first is in the flow. In the flow, it's asked for like a key from the flow parameters, and then you need to enter that key. And then once the flow has that key, the flow will check with the account key state if the key is matching with that that key that stores in the account key state. You see the user ID, it can be, you know, Alice, Bob, or Charlie. And then the account key state basically is Charlie's external public key is the following. And then once everything match, so every time you execute the flow, you need to pass in a public key. Well, you pass in some key, and then use that key, and then there's yes. So the follow-up question is, so it's not the real Corda transaction signed by the custom key. It's a validation code in the flow or contract level to verify do the OAs. Let's just say that, do the OAs with external key. Yes. So that's why I say, is, you know, from the beginning, is from the design level to to avoid or like detour what is default, right? But it allows you to achieve that. So you can now on your mobile phone, you get a text notification saying that, okay, the parent node's gonna do a transaction on your behalf. Do you agree? If you agree, you enter your key, and then the parent node gets your key, run the signature algorithm with the key that's you store on the parent node. And then, of course, it's not like entering a password. You can do the Martin Hellman encryption again, right? So make sure that the parent key cannot just pass in the public key by itself. But that's just the encryption part. But yeah, you get the idea. Okay, all right. Looks like all the question is answered. And then the life cycle is, if you lost the key, the node operator gonna work with you to get an update of your new key. Okay, so that's that. Second example is the ledger and the on-ledger and the off-ledger data synchronization. So this one is primarily on basically the reading the data, and then basically in a production level system where you read data, and then sometimes there's a latency between a transaction is formed on ledger and and then when your backend database is getting the transactions. Yeah. Oh, and so that's a problem. And then the solution is use a durable message broker having at least once delivery semantics, and then ITPollen consumers. So a lot of technical words, but we can expand here in the diagram. So how does this problem, like what's the problem, right? So we basically, every time we work with customer, we try to tell our customer to make the ledger light, meaning make the ledger only record transaction related information, because that's going to guarantee you or that's going to give you a much better TPS, because on basically every industry, that's what people would like, higher TPS. That means equals less operational costs, meaning faster turnover rate, etc. So that means you will have an external system that's basically takes or records the on-ledger data to sync with your off-ledger system. And once you deploy a messenger broker, then what happens is you can, once the data is produced on the ledger, it will use the message broker to send it to the external system, and then it can store on the database. And yeah, so external keep track of the message with the identifier and then already consume. But in the real production environment, sometimes or most of the time we are seeing our customer doing is they have APIs, or they have the web app, the like end use applications. They will do query from the ledger directly, and also from the consumer external system from the database, like doing it together. So what you will see is, boom, you have like 3 transactions running on the ledger, talking to other node, talking to other companies, and then it's settled, and then it's sent to the message broker, and then on the external system is getting it, right? So 3 already done, I'm sending 1, the external system taking 1, and then message broker clear out, and then another one coming in, another one coming in, and then it just finished the 3. That's done computing on the ledger, right? And then 1 is gone to the external system, and then 1 is dissolving. But then at this time, boom, a query that happened from the end using applications at the same time, right? 1 directly from the RPC to check the data integrity, and another one from the HTTP, probably just like a internal ledger keeping or like a data keeping system or something. Then you will have an inconsistent view of data because of latency or whatever reason, right? Or like, sometimes it's leaving like the security, or like there's just time to process data. So on the external system, you are seeing 2 pieces of the data, transaction of the data, and then on the Corda ledger, directly from the API using RPC call, you are seeing 3 pieces of the data. Then this is inconsistency for the view of data. So what's the problem to take care of that? No, what's the solution to take care of that? We are suggesting or recommending a batching of the data. So you have 3 transaction generating, and then you put like basically a stop mark, and then you group them together. You send it to the message broker, and then the message broker will send those 3 batch transactions to external service, the database, and then it's gonna leave the message broker, and then boom, send like a finish mark on that. And then lastly, when you do the query, you will see a consistent view of data. Right now when I'm talking about it, you will think, okay, this is very intuitive. Everybody should, do it. Everybody should think of that. But I can tell you, I was recently working with a customer. Of course, I'm not gonna tell you who. They are basically not realizing that issue until they actually build the POC. No, of course, it's not production level, but when they build the POC, they didn't realize it will become an issue. So basically, they have 2, how would I say? They have 2 states running in parallel, and then one is basically the high level or the overall level balance of everything happening in the node, and then they have like a smaller or the sub balance of each individual accounts, or you can say individual transactions. So the issue is every time you want a new transaction, smaller transaction coming in, is compute pretty fast, and then you can have a 1,000 of transaction computing at the same time. You know, the concurrency stuff, like all that is being taken care of from the Corda node. But on the overall level, on a very high level, there's slowly we'll see a exponentially lag of just calculating the sum of the overall balance, because for the smaller transaction, every transaction is by itself. But on the high level, the overall transaction counter, transaction balance are keep updating the same transaction. And slowly the times will like accumulate. And then when they want to do a query, so on the sub transaction level, they can query all the transactions, they will get a number. And then when they query the overall number, then it's a different number. So again, so at the end of the day, we are working with them to come up with basically a time window. So they are doing this periodically, and then we are basically saying after a certain time mark, we are batching this and then added to the overall balance. It reduced basically the load of the overall transaction balance calculation rate, and then it also provides a consistency view of the data. And then you know, right now you are looking at is having basically the producer on the ledger, and then you have the idempotent potent consumer as the external service. You can also reverse it other way around. You can have the external system as a user, as the producer, keep producing information, keep producing data, and then you have the ledger as idempotent consumer to eat up, right? Just consume the data that you produce externally. But again, you know, the solution is like we are suggesting to batch the transactions to guarantee a consistent data consistency. So again, at the summary, we already talked about the top four, but you know, let's just talk about affected non-functional requirements. So data consistency will increase, the interoperability will increase, because now because if you don't have data consistency, you always need to go into the reconciliation phases. Is like finding out what went wrong, right? But on the other hand, the atomic of the transaction will go down. So again, no best practice, is always case by case, and then those are all basically what we have seen to a specific problem. Okay, so okay, let me look at the QA. So why not create view, some materialized view, and in the view do join between the off ledger and then the on ledger? I mean, I think I mean, if I understanding it correctly, your questions, this is a joint view, because from the customer, like the end user query, they want a joint view from both off ledger and then the on ledger part. The issue is the data inconsistent between the ledger and then the consumer of the data, because the latency of the message broker. Yeah. So okay, maybe I'm not getting your question correctly. You can, you know, follow up with that. Next question is, the transaction will be driven from the client app. Most often we may not know end transaction as they flow into DLT. How does this help in packaging as block? Most often we may not know end transaction as they flow in DLT. Sorry, I'm not getting that either. So let me try to see what you mean. So if we're looking at the chart diagram right now, the get/asset/123. So that's the client app. The end transaction. What do you mean end transaction? Oh, I think I know what you mean. So you don't know when is the green dot will happen, right? Is that correct? So you are saying from the end, from the client app. Oh, yeah, green dot. So that's where when you build the Corda app, when you build the Corda app, you need to, get, come on, like today's session is all about design. So it's like when you design the applications, you need to set up like checkers. So right now, as I said, in the recent client use cases, we just use time window, as a batch. So, oh, I see your questions. Okay. You see here, caveats. So that's when, okay, if the ordering of a message, no, not the ordering, like if it's a serial transaction, yes, then you may have issues because you might batching them into a different group. But our use cases, or like the things we learned from our customers, is the time window works with them, because each transaction with one another is independent from one another. And actually that's how Corda works, because every transaction is independent from one another. So you should not see a transaction that's waiting for another transaction to come. So right now here in the red dot, they are independent from one another also. So yeah, I understand your questions. I'm thinking as well. Well, I mean, it's not part of the PDF, but the PowerPoint. I'm thinking it right now. So so if you are in a serial transactions, yes. So the client app might not know when, or even when you design the Corda app, you may not know when to stop the transaction. Okay, on top of my head, I can think of something. So every time you run transactions, you can keep track or use a reference saying that the following transaction belongs to the same sequence. And you can, when you design the application, of course, you're gonna know what's the last stop of your business logic. What you can do is waiting for the last transaction to commit it. If they gonna happen in sequential. So that's one. Or use a time window. Yeah. So those are two options that I have on top of my head. So the solution we are offering here in this PowerPoint is basically to solve the dirty read problem, to simply solve inconsistency of data. But the question you just asked is a different level, the different angle of the question. Okay, follow-up questions. If there's a sequence of data and you want to know when to stop, then there's approach with poison pill, send special data that indicate that's the last item. Yeah, that's what I was thinking as well. So when you design your Corda app, of course you're gonna write different flows. and then you will know which is the last stop of your business logic. So maybe just wait till that flow comes in. Okay, so that's the third section of the webinar. The last one is good practice. So this is for the bit coding part. So we talk about design, right? When you design the Corda app, now let's talk about actually coding. So we have 5 examples, I think. Take a sip of water. Oh, it's already 4:55. All right, so I gonna go quick on the last section. So why we call it good practice, because there's no best practice. Everything in software architecture is a trade-off, right? We suggest good practice that works in most situations. So this is it's just like big talk. Demonstrate the do or don'ts, inspiration from the effective Java for Corda app. We get it from our peer review from the Corda experts, and those are not absolute. Exceptions possible. So those are the disclaimer. Okay, so the first one. So we do not we will suggest avoiding string literals for contract names. So actually we were just laughing. We were internally laughing about this because a lot of our samples are still like this. So I guess after today's sessions we have this team will have a lot to do. Yeah, so I mean, originally for the sake of simplicity, we just use string literals, but yes, in the productions, don't do it, because if you want to update something, you always need to go back and change it. If you forget to change it, your Corda contract jar is not registered. Always use the canonical name of your contract class. That's the first one. Second one is avoid empty classes for command. So yeah, we take care of this in some of our samples. Is in the contract there's a command class. There are many ways to avoid empty classes for command. So basically it's saying that do not make your verification, like the one verify method in the contract, super long. This stack suggests you basically expand the contract command classes as the interface. You can write the verify method within here, or you can use helper method, just any other Java programming projects. You can write helper method below the master verify, and then in the verify method you can just call it. So basically it's just for the contract, don't put code in just one big verify method. Yeah, when we actually write, how would I say, a little bit more contract heavy samples, we do that. So yeah, definitely do this. Basically when you are writing or developing a production ready contract, make sure you're using helper method in the contract. Next one, reuse the flow sessions. So actually in most of our samples we don't show this, but this is a very how would I say, very uncommon to demonstrate, because most of our samples are almost single flow business logic transactions. So you just take the flow, you run the flow, your counterparty receive it, done. That's it. But in the production level Corda app, you will have flow happening one after another. So between, like when you initiate a session flow session between one party to another party, you can keep it open. It's kept open. So your next transaction can just you can pass in as a parameter. of the flow session and then just continue to use it. Yeah. So that's the reuse of the flow session. So if you look at here is, that's called a message flow. It's take, just normal parameters, and then it's will initiate the flow session. And then here, initiate the flow session, initiate flow to counterparty, you get a session, and then you send message. So that's just a single flow. Most of our samples are like this, but it has a reason because we don't have any follow-up flows. But in a larger project, once you initiate the flow, you can keep reusing the flow sessions and then receive message and then send back. So here is you can take in the flow sessions as a parameter of your flow. Okay. Next one is avoid too much data in a single Corda transaction. So this one is pretty intuitive. We also say that in our sessions is we want you to build a Corda app that's keep the transaction light, not only because there is a maximum transaction size and the maximum message size that's the Corda network limit, like even it's your own Corda network limits, it's a trade-off between your big transaction and then the TPS of your network. So what we are recommending is reconsider the need for strong consistency at a global scale. Consider lightweight states with static fields. Regroup the state, reduce the overall Corda transaction size. So if people care about atomic transaction, they can dump like 5 inputs and then 5 outputs, but that's make the network too heavy or too heavy to send the transaction. That will reduce your TPS. So you can consider to reduce or like separate. You send all the transaction for trade for party A, and then separate another transaction for all the trade for party B, and then to make it 2 separate transactions. So that's the first one, the fourth one, and then the last one is decouple state information into state and then link them using pointer. So it's just don't do nest object. So here as an example, we do not recommend is you have one state and then inside of the state, one of variable is another state. So you can resolve it by using linear pointers, and also you can achieve future updates of the so-called nested state without affecting the other state, because you are just taking a linear pointer of the other state. So they are technically linked, but they are not affecting one another. Because every time if you are doing the nested states, anytime you want to update the auction item, you need to update, you are updating the bit state. So that's the 5th example. So it's all on the coding level. It's also something that's like if we don't tell you, you probably will run into some issues, and then you'll realize that. So we are trying to collect our knowledge and then build into basically a knowledge base, and then start teaching or educating our community on this. So how are we getting the recorded videos? I actually go to the first question that I answered in the QA. The link of the author of this session had a talk about this during CordaCon, and then you can basically get the full videos of this. Okay, that's all the things I prepared for today, and actually it's 4 minutes past the clock, so actually it's a whole 60-minute sessions. All right, thanks everyone for coming. My name is Peter. I'm from the R3 developer evangelism team, the DevRel team. So if you have any questions, oh, where's my Zoom? Here. If you have any questions, feel free to email us at devrel@r3.com. Let me see how I can. Oh, as a panelist, I couldn't ask the question. Okay. Then let me type it somewhere. Here. I just type it in my presentation, and I will share my screen again. Here. Right. So if you have any questions, feel free to email us at devrel@r3.com. Again, this session, I think it is recorded, but we will not share the recording of this one. We will share the original videos that Arnab has a talk. Our professional solutions engineer had a talk during CordaCon. The link is in the QA, the first question in the QA. Okay, all right. Thanks everyone for coming. Enjoy the rest of your day, your night. Bye. All right. Thanks. Bye.